Hello class, so I just wanted to make sure you were fully prepared to do the homework on the Delta Math assignment. You should have been able to do the first two topics, but we're going to take a look at the other problems, specifically on compounding and half-life. Alright, and converting. So if we start with compounding for future value, this problem has an example that is compounded continuously, which I will do second. So I'm going to try and find one that's compounded daily. So there's a similar formula to the one we're used to. We're used to y equals a to the 1 plus or minus r to the x power. Now this formula could also be written as a, meaning our final amount is equal to p, which is our principal amount or starting amount, times 1 plus r to the r over n to the xn power. And when this happens, this is called the compound interest formula. And this occurs when the interest rate is anything other than once per year. So this formula is normally used for once per year. It actually comes up when you plug in a 1 for n in the exponent and in the denominator. So in this case, we're talking about an account that accrues interest every day, which is more often. Believe it or not, the more often you collect interest, the higher the interest, the amount of money you will make will be worth. So we're just going to plug in the values and just calculate this as normal, nothing new here. So we want to find the final amount in this case, so that is our A value. The principal amount in this example is $3,900. It says it is daily, so plus 1 plus 0.039, which is 3.9% as a decimal, over 365 because there are 365 days a year, and the interest is calculated every day. For the exponent, we're going to write 365 times 5, which is how many times the interest will be calculated, and then this is just something we can plug into our calculator. I will do that on screen as well. So it's $3,900 times 1 plus 0.039 over 365. Close that parenthesis, close the other parenthesis, to the power of 365 times 5, which should be $4,739.66. 4739.66. 4739.66. It said to round to the nearest $100, so that means we're going to be rounding this 3 down to be $4,700. Let's see if that answer is correct. And it was correct. All right, so this is the compound interest formula. Solving for all the different things can be looked at by looking at the different examples. We'll do one of them. We'll solve for time using a continuous interest rate. So I'm going to erase this example. I'll leave the compound interest formula here. And I'm looking for one that's compounded continuously. Monthly is 12 instead of 365. Annually, quarterly. I'm looking for continuous. Quarterly, continuously. All right, so in this case, we're going to be asked to find for time. So we're going to be solving for our exponent, which is going to be our variable here. So we're going to be looking for our variable. Now, when you're doing continuous interest, what happens is we're really calculating interest at all moments, which is when the n value, instead of being like 365 for daily or 12 for monthly, is actually going to be infinity for at all moments in time. So this actually simplifies to another formula, which is A is equal to the principal times E to the RT. E is just a button on your calculator. You can find it by pressing second divide for the E button. Whenever you do log E, you can just press the button on your calculator that says ln instead. So we're just going to fill in what we have here. We want to reach $9,890. That's the final amount we want to have. It says we invested $8,400, and the interest rate is 0.019, or 1.9% interest, and we want to solve for x, our unknown variable in this case. I left out the e in the formula, very important, because this 0.019x is on the e. So the first thing we're going to do is we're going to divide off the $8,400. And we're just going to have to use a calculator to get that amount. I'm just going to use it on my real calculator, not on my iPad here. So 9890 divided by 8,400 is 1.177380952. You'll notice that I just write down the entire decimal. I don't really worry about rounding until the end of the example. I just write down whatever the calculator gives me, because every time I round, I'm making my answer less accurate. Next, we're going to write this in log form. So it's log of base e of our result, which was 1.177380952. This was all equal to our exponent, which is 0.019x. So I'm just going to have to type a lot of this into our calculator. So I'm just going to select everything on the screen here and move it out of the way so I have a little more room to work here. So I'm just going to move all this up. And that's fine. All right, so we're just going to calculate this on our calculator. I will be using the button on my calculator specifically that says ln instead of log e. It means the same thing. I'm going to press ln 1.177380952, which gives me 0.1632997166 equals 0.019x. Now I just want to get x by itself, so I'm going to divide both sides by the 0.019. And that will give us our final answer. X is equal to, divide by 0.019, and that gives me 8.594721. I get more decimals, but it only is going to ask us to round to nearest tenth of a year, which is here. So that should be 8.6. So let's just type in 8.6 to check our answer. And that is the correct answer. Alrighty. So that was a continuous interest problem using the continuous interest formula. And now we're just going to take a look at converting from one form to another. And then we'll look at half-life. So let me erase what we have here. So converting from one form to another means that your exponent starts in one form. In this case, our exponent is in this form of 1.1 to the t power, but our final answer wants to be written in, a is always 8,300, by the way. That's never going to change. Oh, did they want it to be written as 2? Oh, interesting. They have a very interesting way they want us to write this example. They want us to change the 1.1 to a 2. I haven't even really seen an example like that before. Let me take a look at the solution. Interesting. I wouldn't have thought to do it this way. I'm going to recommend you watch the help video for this example. This is probably a bad choice on my part, but I'm going to look for a different example because I was looking for something very specific to convert with. Well, that particular topic is giving me some trouble here. Seems to have frozen up a bit. Normally they ask you to just rewrite it as something. Alright, well they gave us another example, but I'm looking for a very specific example where the number is mostly the same. Okay, this is more what I was looking for. They give you $89,000 to the 1/2 t to the 8 power, and they ask you to write it without the 1/8 here. So the way we're going to do that is we're going to apply one of the exponent rules, which is to replace the t here with a 1/8 times t. So the rule for exponents is x to the a b is equal to x to the a to the b. And this way we can just simplify this with our calculator. We'll get 89,000 to the t. 1/2 is 0.5, so 0.5 to the power of 1/8 is equal to 0.917004, and it's just around 4 decimal places, so 89,000, and then this is going to be, this keyboard's massively in the way, 0.9170. So that is the way of dealing with just changing the exponent to have a fraction, to no longer have a fraction. I wanted to take a look at an example where we make it have a fraction. So looking for that in here now. Okay, so this one wants it without a fraction. So this is more what I was looking for. So 790 to the 1/2, I'm sorry, times 1/2 to the t over 5. So we're going to use the same rule we did a moment ago, which is to rewrite this as 1/2 to the power of 1 over 5 to the t. And we're just going to simplify this expression, and then there will no longer be a denominator in our exponent. So this is 1/2 to the power, oh, not 1/2. The whole point of this is it's not going to be 1/2 anymore. So it's 0.5 to the power of 1/5, which is going to be 0.87055 to the t power. So the purpose of this is to see what your annual interest rate is. In this case, this is a decay of 13%. So it's a decay of approximately 13%, but written in the form it was originally written in, it wasn't very clear that was happening. So if we rewrite this as 790 times, I can't see the decimal, 0.8706. Unless I rounded incorrectly, that should be fine. All right, last thing I wanted to talk about was half-life. Well, I'll just briefly talk about half-life since I got logged out of Delta Math for some reason. So half-life means, let's say I had 500 grams of something, and it's going to halve in value. This would mean every 1 year. But if I said it halves in value every 10 years, I can rewrite this as x over 10, meaning when this reaches 10, it will halve. So this is what a half-life formula looks like. And if I said how much would be remaining after 15 years, I could just write 15 over 10. In other words, it's 1.5 half-lives, or 1.5 groups of half-life.